Well, since we're on the subject of special triangles, here's another special triangle. An equilateral triangle is a triangle in which all the sides and all the angles are equal. Well, equilateral triangle. In this case, if I had an equilateral triangle with a side of 2, all the sides are also going to be a length of 2. And what about those angles? Well, certainly you know the answer to this one, right? That has to be 60 degrees, right? This has to be 60 degrees. By the way, it's not just that it's 60 degrees, right? Because we could say that, well, if the internal angles of a triangle add up to 180 degrees, then the internal angles of a triangle add up to pi radians, and there's 3 of them. So we could also say that this was pi over 3 radians. Okay, well, what makes it so special? This is not a right triangle, Professor Peoples. What do I do with that? Well, in this case, let's just take the triangle, just chop it right in half. What could we say about that? Well, if each of the sides before were equal to 2, that means that this side that we just chopped in half has a length of 1. Right? And that's really easy to remember because now I can use my Pythagorean theorem and work out the length of this third side because whatever its side is, right, we'd say, well, that side, I'll call it y squared plus 1 squared is going to equal 2 squared. Y squared will equal 4, and I subtract 1 from both sides. So y squared is equal to 3. That means that this opposite side must be the square root of 3. And that's also an easy one for me to remember because now anytime I run into this 60-degree angle or pi over 3 radian angle, I can find my sine, cosine, and tangent values relatively quickly. Let's do it in radians this time, just for a little variety here. Let's see. If I were asked to find the sine of my angle pi over 3, well, opposite over hypotenuse tells me that this must be the square root of 3 divided by 2. If I take the cosine of my angle pi over 3, that means I'm going to take my adjacent over my hypotenuse side, and that's got to be 1 over 2, 1/2. Nice. And the tangent of the angle pi over 3 has got to be my opposite over my adjacent side. In this case, that opposite over adjacent side is radical 3 over 1. Well, that's just radical 3. I can also very quickly find my cosecant of pi over 3. Doing so, I take my hypotenuse over my adjacent side, over my opposite side, pardon me. Hypotenuse over opposite is 2 over the radical 3, which is to say, in rationalized form, 2 radical 3 over 3. For the secant of the angle pi over 3, we recognize that to be the hypotenuse over the adjacent side. Well, that's just plain old 2, or 2 over 1 if you want to put it that way. And then the cotangent of pi over 3 is going to be the adjacent over the opposite side. That's 1 over the square root of 3, which rationalizes as square root of 3 over 3. But the nice thing about equilateral triangles is that when we take them apart, we get 2 equal triangles, 2 very similar triangles right here. Let me give you this one, right? This was a 60-degree angle. Well, what's the other angle here? Well, that's right. It's complement, which is 30 degrees. So if I were to take this triangle and just bring it down here, and let's rotate it around here. There we go. Oh, rotate it around here, and look specifically at our other angle right here. And let's put this in radians also. This 30-degree angle would be pi over 6 radians. And of course, the short side goes along with the short side right here. The hypotenuse is still 2. That means that my adjacent side becomes square root of 3. And a very interesting thing happens now. Turns out that if I were to take my sine, let's try sine here first. If I were to take my sine of the angle pi over 6, which by the way is equivalent to saying the sine of the angle 30 degrees, I'm going to get 1/2 this time. You'll notice that the sine of pi over 6 and the cosine of pi over 3 are equal to each other. This is why they're called complementary angles. The cosine is the sine of the complement. Get it? So they're very closely related, and we can just go down the list right here and note that the cosine then of our angle pi over 6 will be the same as the sine of our pi over 3 because they're complementary. So radical 3 over 2. Tangent is complementary with cotangent. So if I take the tangent of pi over 6, it will be the same as the cotangent of pi over 3, which is to say radical 3 over 3. Likewise, our cosecant of pi over 6, my pen just doesn't like to work with me today, pi over 6 is going to be the same as my secant of pi over 3, that's 2. The secant of pi over 6 is going to be the same thing as my cosecant of pi over 3. Again, cosecant and secant are complementary. So that's going to be 2 radical 3 over 3. And the cotangent of pi over 6 is going to be the same as my tangent of pi over 3, and that just comes out to be radical 3. Good stuff.